Last time we went over a brief tour of Linux. We had a little discussion about what an operating system is and how it works. We talked a little bit about the major differences between Windows and Linux, and we went over some of the basic but very useful tools on the Linux command line. Today, and we also started to talk a little bit about systems administration and what it is and how it works and what the basic ideas are. And where we left off from yesterday, I keep saying yesterday, I mean Tuesday. From Tuesday, where we left off was we started talking about the Linux file system in general. So when you install a Linux distribution, either CentOS or Linux, either CentOS or Ubuntu or Fedora or Gentoo or one of the probably thousands now of other versions that there are out there, you at the very core of the file system, at the very core of the operating system, you will see this. And this is everything this is the basic heart of the operating system. It starts at the root directory, and everything you see on the screen right now is held within that root directory. The bin directory contains various programs that you might need to run. It also contains a lot of the actual binary programs for the various commands that you would run on the Linux command line, like ls, cd, history, the various things that we saw last time. The boot sector the boot directory there contains the boot sector. This contains the Linux equivalent of the Win32 file along with other system essential files. And basically, it's a good bet that if you delete anything in there, something bad will happen, so don't do that. The dev directory contains a listing of folders that contain mounts to various devices. Now these are little connection points that basically say that will allow you to go from your computer to various other data containing systems, either a flash drive, a CD drive, a DVD drive. You can a DVD drive, a external hard drive, and various other things. The etc file contains various configuration files that need to be persistent across their shutdown and restarts. So whenever you turn off and turn on your computer, there's probably something running in the etc file that will help make sure that the operating system looks very similar today. It looks pretty much the same today as it did yesterday. The home file contains all of the user directories. So we'll talk a little bit more about this later, but in Linux, every single user, including you, the owner of the computer, is a user, and they all have the same level of permissions. So if your username on your computer is Alex, which for me it would be, then I would have a home directory under home here called home/Alex. And then all of my documents, all of my videos, pictures, etc., all of that stuff would be contained under my home directory. And by using this, Linux is able to host multiple different users. And so whenever you log in, the computer will set you up so that when you turn on the terminal, you'll be dropped into whatever your username's home directory is. The lib directory contains a whole bunch of core libraries. This is another one of those things where you don't want to delete anything from this directory because bad things will probably happen. Oftentimes the lib directory will contain a lot of the peripheral operating system internals that aren't necessarily part of the boot sector, but they are part of the Linux kernel. And they help provide core Linux services. Media is another place where you might see mount points. So for example, a lot of times USBs, CD drives, and various things you would plug in will end up under media. but dev is, but a lot of times they'll also end up on, they'll also get an entry under dev. And that's just because dev is contains a registry of all devices. But media contains a registry of only devices that you plug in and things that aren't always a part of your computer, like USB drives, CD drives, etc. The MNT file is where you would put other file systems that you might want to plug into your Linux system. A good example of what MNT might hold is if you have a connection to a remote file system. So if you want to have a persistent connection to, say, a cloud server, the connection point between the cloud server and your computer would probably end up in MNT. Assuming this was set up as something called the root user, which is basically the systems administrator. The OPT file contains various miscellaneous files. In a lot of HPC settings, you'll often see the actual programs that the users will use, like bioinformatics programs, material science programs, compilers, MPI installations, and various things that the users will need. A lot of times those will be installed under opt. Proc is internal stuff. It's short for process, so it contains a lot of log files, a lot of information about, and a lot of temporary files that talk about results and errors in the various processes running in the background. Root is the lowercase root directory here is the root user's home directory, and what the root user is essentially the Linux equivalent of administrator on Windows. So whenever you install a program on Windows, often you'll get this little pop-up that says, "Do you want to run this as administrator?" And you'll click yes, and then it'll eventually install for you. Root is the equivalent of that. So when you install a program on Linux, you'll often get a pop-up. You'll often get a pop-up that says you do not have access to such and such directory. Usually something in here, and it'll say you need root access to do that. So then you'll type the command. So then you'll type the command again with sudo prefix to it, and we'll talk a little bit about that later. And then it'll ask you for the root user's password, and then it'll go ahead and install. SBIN is systems binaries. SRV is various other services. TMP is where a lot of temporary files, things that are written out to but then deleted, will get written out there. USR is another place where you might see user-facing programs and libraries installed too. And this is often where, if you're running a Linux desktop, this is often where they're installed. And var is various variable libraries. And lost and found is the equivalent of the trash bin. So, any questions on that? Oops. Okay, if not, I will continue then. So, when you first log into your Linux system and you bring up the terminal, you will find yourself in, you'll get a terminal that looks something like this. It'll usually say either the name of your computer, and then it'll either say your username at the name of your computer, and then it'll have a little tilde and then a hash symbol. The actual format of this depends on what shell you're using. Either C shell looks a little different, bash looks a little different, but they're all roughly the same. They all roughly look like this. Sometimes instead of giving you the username at computer name, they'll just say bash. So when you get dropped in there, you will start at a directory you'll start in your home directory. So if you were to type pwd, this will show your present working directory. And if you have just started a new terminal, then pwd should say /home/Alex or /home/ whatever your username is. Consequently, this also depends on the setup. If you are running a cluster in a supercomputer cluster, you might have a prefix before home, like on RCC systems, it would say gpfs/home/ my username. If you type ls, then you will get a with nothing after it. Then you'll get a listing of all the files and directories that are within your present working directory. So in this case, documents, videos, pictures, mydoc.odf, mydata.odt, and myinfo.txt are all held within home/Alex. If I wanted to create a new folder within this and I didn't want to use the graphical user interface, I could type mkdir, my folder, and then if I did ls again, you would see documents, videos, pictures, and then my folder, and then the rest, and then my doc, my data, and my info in here. So this is one way of creating a folder within the current directory you're in. If I wanted to change the present working directory to a different folder, I could just say cd my folder, and this would be the same as saying cd/home/Alex/my folder. Of course, I could also type cd/home/Alex/my folder, and generally, if you want to go down the directory tree, you don't usually have to type all the prefixes. But if you want to go up the directory tree and then down a different branch, and then down a different part of the directory tree, you're probably going to have to type most of the full file path. So whenever you start a new Linux terminal, the first thing it will do is it will run something called the bashrc file, or the bashrc file and the bash profile. These are files that basically set up that every time you start up a new terminal, they will set a whole bunch of things they'll set up a whole bunch of variables and a whole bunch of stuff that collectively together make up your environment. And these things basically control the configuration of your terminal, and they will make your life a lot easier. These are things like these things are things like the path, the PWD, the home variable, and the X authority variable, among many other things. So path is we'll talk a little bit about what each of these is in a little bit, but one way you can see what all is in your environment is to type print env and hit enter. That will print a usually very, very long list of all of the various environment variables that are set. So one good example of how environment variables make your life easier is the path environment variable. The path environment variable is a variable that says that will tell the computer every directory that's in this set of directory files. This is where you should go look when I type a shorter version of a program I want to run. So for example, if I go back here, you might see that the path variable is set to /user/bin:/bin. This colon is essentially saying my path variable includes the user bin file and the /bin file. So by using this colon, you can append as many directories as you want. And so this is important because this way I can type things like ls or pwd and hit enter, and the Linux terminal will go look in my path variable and go see if there's a program called ls or pwd. And this is really important because at the end of the day, all the Linux commands that you run actually are compiled programs that you would run that the terminal needs to be able to find. So adding things to your path makes it so that you don't have to type out the full file path to the binary that you're trying to execute. So for example, if I didn't have this path variable and I wanted to run ls, I'd probably have to type /bin/ls and then hit enter. And I couldn't just type ls. So that's one way that makes life a lot easier. The path and the LD library path. LD library path means basically it usually is used to tell compilers go look in these various directories for libraries, for the various libraries I'm trying to link to when I build my programs. It makes compiling your own code a lot easier. So if you want to see if you type print env and you hit enter, you're going to get a very long list of environment variables, because usually Linux environments will set up a ton of them. But if you know the name of the environment variable you want to look at, and you don't want to have to go dig through all that list, you can simply type echo $, and the name of the variable you want to look at. So if I typed echo $home, then it would print out /home/Alex. If I typed echo $pwd and I happen to be in a subfolder of Alex, then it would print out home/Alex/ in this case project. So there are a bunch of different ways. So so as I was talking about before, the path variable makes it so that the operating system can go find the various binaries that you need to run. But sometimes you really just can't. But you can't just add everything to your path, because if you do that, it's going to take forever. It's going to take forever to go find stuff. So one thing you can do is, if you want to know where something is, then what you can do is use the grep tool. The grep tool will actually allow you to go look through giant lists of results and find only the things that you want. So for example, if I had 3,000 files under /home/Alex, and I wanted I knew I wanted something that was called text, but I wasn't quite sure what it was, I could type ls/home/Alex, and then the bar, which is called pipe in Linux. The pipe key here, it's essentially shift and the / character. And then I would type grep text. And what this would print out is a list of all the files that contain the word text, of all the files and folders that contain the word text. So this way, it'd make my life a little bit easier, because I wouldn't have to go looking through 3,000 files. So are there any questions on that? If not, then I will go ahead and continue. So this usage of the grep command is actually a very good first example and a very good segue into talking about the piping and redirection of output. So what this command is actually doing is it's saying, okay, first run the ls command on home/Alex, then give the output of that command to the grep command, and run grep text on the results of the ls command. So by doing it, and you can do this piping and redirection of output a bunch of times. It doesn't just have to be done once. So I could type ls/home/Alex/ or pipe to grep text, pipe to grep.txt, and it would slowly filter things down. So usually the result of whenever you type a command in Linux, usually the result of that command will go immediately to the screen, and that's it. And if you're just starting out with Linux, that can make it pretty hard to figure out, okay, I got the results, but I want to do something with those results. How do I do that? So in order to do that, you can use piping. You can basically add this pipe character, and what that will do is it will send the output of the command to the left of it to another command that's to the right of it. So in this case, in the case above, I would take the ls command, get the output, and then the output would go immediately to the grep command, and the grep command could then run on the results from ls and give me give me more filtered results. So by using this, you can actually pipe together a whole bunch of commands. So I could type one command, pipe another command, pipe another command. so on and so forth. And that can be really useful if you're trying to do some serious filtering of results, especially if you have huge numbers of files and you want only a specific subset of them. That way, this can really help with that. So another thing you can do is actually you can output, instead of outputting the result of a command to another command to be filtered farther, you can actually write out the results of a command to a file. And you can do this by using the sort of double right caret character. So if you type two right carets, so if you type like ls/home/alex right caret, and then myfile.txt, and you hit enter, you won't see anything pop up to the screen. Instead, you'll see a new file. Instead, a new file will show up in your present working directory called myfile.txt, and within that file will be the results of the command that you ran. And this is actually pretty useful because sometimes you might want to run a bash command, and you might want to then take the results of that bash command and then run it through a different program, like a Perl program or a Python program or something else. So by using this, you can actually get the results in a format that another program can use. Consequently, it's also a good way of saving the results of a command. So we talked a little bit about the piping, redirection, and grep commands to find stuff, but there's also a couple of other ways to find specific things within the Linux file system. If you knew you wanted to find a file called myfile.txt, you could simply type locate myfile.txt, and it might take a while, but the program would go dig through your operating system and go find something called myfile.txt. Another way of doing this is to type the find command, and this is the locate command is fine, but it will always start at the same place, which is up at the root. If instead you don't want to wait for very long, and you have an idea of where the file might be, one thing you can do is use the find command, and you can say find within the find /name or -name my file. What this will do is this says find starting in the / or root directory a file that contains the name my file. And this is really useful because say for example, I knew for sure that file was in /home/alex. What I could do instead is type find /home/alex as I did here, -name my file. And this would take substantially less time than the locate file. And so what you would be left with is a series of results where the name of the file contains the word my file, but all of the results will be underneath the /home/alex directory. So both of these are really useful tools for finding things in Linux. The locate tool might take a while to run, but the find command is a good way of cutting down on the amount of time that it might take. So any questions on that so far? If not, then I will move on to managing files on the command line. So the command line can be used to create new files and manipulate old ones, and you can even copy and delete files, although especially with the deleting of files, you need to be very careful because when you use the command line, the deleted files don't usually go to the lost and found; they go away. So if you type, so we'll get to that. We'll get to that in a little bit. So if you want to create a new file in your present working directory, then you can use the touch command. So if you just type touch and then X, you will get a new file that is titled X. If I wanted to call it myfile.txt, I could say touch myfile.txt, and it would create a new raw text file called myfile. If I wanted to print something very specific into a given file, I could type echo in quotation marks whatever it is I want to type, and then I could use a single right caret to print that, to send that to the X file, to a file called X, or to a file called myfile.txt. And that's actually pretty useful, because you can use that as a tool to log the results of various programs. You can also use that as a way of typing from the command line to a specific file. The cat command, cat is short for concatenate, and if you type cat X or cat myfile.txt, as long as that file exists and is within your present working directory, then what the cat command will do is it will take all of the contents of that file and print it to the screen. And this is essentially the same thing as the more command. If you type more myfile.txt, then it will do pretty much the same thing. But if you type less myfile.txt, then it will type up to a certain number of lines. And then the number of lines that it will print out will really depend on how your terminal is set up. And this is really useful. I actually use the less command all the time, because particularly when I have to go digging through log files, the files that I'm digging through could be hundreds of thousands or millions of lines long, and I don't have time. I don't have time to dig through all of that. So instead, what I could do is type less, and then start typing the down key. And what that will do is rather than me having to go up and down and dig through every single line, it would allow me to only look at a certain group of lines, and it sort of acts like command line scrolling. So you can scroll down in the file, and you can scroll up in the file, and you'll only be looking at a small block of lines, and that just makes things easier to read. Like I said, especially if you're working with giant log files, the less command makes life a whole lot easier than cat or more, because not only might you have to wait a while for the cat or more commands to finish running, but it's just easier to read. Okay, now we get to the RM commands. So if you type RM and X, so in this case, let's say my file is called myfile.txt. If I type rm myfile.txt, that command will go look in my present working directory and see if it can find a file called myfile.txt, and then it will delete it. Now, like I said before, this does not go to the lost and found file. It's gone. It gets deleted permanently. And usually it won't even ask you. Usually it won't even ask you if you're sure. It will just do it. So the RM command is very, very powerful and very dangerous. So another thing you can do is type rm star.txt. Now the star in there is something called a wildcard, and what that means is it says delete anything that is a text file from my present working directory. So if I've got 100 text files and I don't want to go through the trouble of deleting every single one of them by hand, one at a time, I can type rm star.txt and it'll delete all of them for me. Now, again, you have to be really careful with this, because you got to be very sure you really want those deleted. There are a large number of options with RM. consequently, never ever type rm-r/. That will delete the entire file system and everything in it. I think it's rm-rf/, but never do that. That's like deleting that's like taking my computer and putting it in the trash bin. It will blow up your computer. It's not a good idea. But one thing that is neat about the rm command is you can type rm-r star.txt, and let's say you have a whole bunch of files, a whole bunch of folders and subfolders in your working directory, and you want to get rid of all the text files in all of them. And that would take a long time. That would take a very long time to do by hand. So what you can do instead is type rm-r star.txt, and that will start in your present working directory, and then it will delete everything that's a text file in your present working directory and everything below, and all the folders within your present working directory. So again, you want to be very, very, very careful with that. We talked the mkdir command. I think we talked about that a little bit earlier. That's a command line way of creating a new folder within your present working directory. rmdir is a way of deleting a directory within your present working directory. And mv is short for move, and it's basically the command line version of cut and paste. It basically says take a file called X, or in this case, take a file called X and rename it to be Y. So essentially, it's you can think of it as move everything in X to Y and delete X. So that's actually a good way of renaming. That's a good way of quickly renaming files in the command line. So are there any questions on the working with files and deleting files? If not, then we will continue on. So all of the commands that we've talked about so far are very good, and they're very useful, but they don't really help you if you want to open a file and type in it. Now, if you want to open a file and you want to start typing in it, like code or just text, you need something called a text editor. Now, there are a bunch of text editors out there. If you use Windows, you might have seen Notepad and WordPad. Notepad is the more basic text editor, but WordPad counts. Word technically is a text editor. In Linux, you'll see things like Emacs, gedit, and a billion others. However, there are actually command line text editors. Things like gedit and Emacs and WordPad and Notepad, those are all graphical user interface programs. Those are all graphical text editors. But there are text editors that are written in the command line, and these include things like VI, VIM, and Nano, among many others. VI and VIM are the two most well known. They're also two of the oldest. VI is just a very simple bare bones text editor. You open it, you type stuff in it, and then you hit I think it's :Q, :WQ, and it will save whatever you typed and exit. VIM is an extension of VI, and it's basically VI with a bunch more bells and whistles. Sometimes it'll do syntax highlighting. It's got a bunch more commands in it, and it's a more complete version of a text editor. And Nano is basically just an alternative to VI. So these are really useful because they can be used to open, edit, and save a whole bunch of different types of files. They can be used to open, edit, and save text files, code files, CSV files, pretty much any file you can imagine. They'll even open files you probably don't want to open, like binary files, because it'll work. You'll just get a whole bunch of stuff on the screen that won't make any sense. So these editors are really good and really powerful because they can open and edit a whole bunch of different file types and you won't get the typical Windows complaint of, I don't know what file this is. What do you want me to open it with? And again, and also they're very useful. They're very useful for cases where you might not have access to a graphical user interface, which admittedly is becoming increasingly rare these days. But in some very low level applications, or in some particular supercomputing applications, you might really want to use a command line text editor. So these are 3 very good options for that. Another thing you can actually do from the command line is download files from the internet. You can use something called the wget command, and you can type wget and a full URL, a full internet path to a file that you want to download, and it will download for you. So as long as your computer's got an internet connection, the wget command will let you download pretty much anything. So for example, at this address, there's a text file called twain.twain4, which is Mark Twain. If I typed wget and this address, it would download a text file. It would download a text file called twain4, and it would put it in my present working directory. If I type wget-o new.txt, it would, and then the URL, it would still download that twain4 file. But what it would end up doing is, instead of putting that in a file called twain4.txt in my present working directory, it would print everything to new.txt. And what I would end up seeing in my present working directory is a file called new.txt with everything that I just downloaded. So that's really useful because wget is used a lot in scientific applications. For example, if you want to download large amounts of data, or if you've got a data or code repository somewhere and you want to bring it into your command line environment, this is a good way of doing that. So, any questions on that so far? Because next up is, oops. Oh yeah, Notepad++ does count. That's a really good graphical user. That's a really good graphical user interface. Text editor. In fact, I actually use that whenever I'm on a Windows computer. I usually use that for coding. And I've actually heard about NEdit. NEdit does work similarly to. It is a neat one. Any other questions? All right. So next up is users, groups, and permissions. So whenever if you're managing a computer or a set of computers that have a bunch of different users, it's very important to be able to manage what those different users are able to do and what files and folders they're able to access. So the way Linux and honestly most systems these days manage that is by creating user accounts. So for example, whenever you log into your Windows computer, you're logging into your user account on that computer. The same thing is true in Linux. And as we talked about a little bit before, every user account every user has their own home directory in the /home file of a regular old Linux desktop computer. And these user home directories correspond directly to user accounts. So whenever you log into your account on a Linux system, you will immediately be taken to your home directory. Now, one thing is that users cannot make changes to anything they aren't explicitly allowed to change. So for most basic user accounts, that means anything underneath their home directory. So any folders and any files within their home directory, the user can change, but nothing outside of their home directory. So, for example, anything in the slash, so for example, a user whose home directory was /home/user1 would not be able to edit anything in /user2. They also wouldn't be able to edit anything in the root directory. So they couldn't go to /bin and then delete something in there or change something in there. That would be something only the administrator, or in Linux terminology, only the root user can do. So for most users, they are pretty much boxed into anything under their home directory. Now because of the way Linux works, you can change this, and so it is possible for user 2 to make certain things in their home directory available to user 1, or available to available to everyone else. So we'll talk a little bit about how that works. So one other thing that comes up a lot is if you have a whole bunch of different users, they might not all be the same. You know, they might be grouped into different departments. You know, they might be the accounting department, or the accounting department, or the sales department, or whatnot. And in academia, they might be research groups. In fact, they usually are research groups. And so what you can do as a systems administrator is you can actually group together these users and set up something called a user group. And what that means is that the user group can share things between each of their home directories, but they can still block out people who are outside of their user group. And also each individual user account can belong to multiple groups. So that's actually really useful, because you might have a student who's a member of, you know, Lab A, but also a member of the computer science department. So they might need to be in both user groups, so that specific user can access things from Lab A and things from the computer science department. So the way that Linux handles this is by assigning every single file and folder within its entire file system a set of permissions. And these permissions take the form of a short string that contains letters such as D, R, W, or X, or dash. And we'll talk a little bit about what the specifics there mean. And what that indicates is it basically shows who's allowed to access what and who's allowed to manipulate the contents of those files and folders. You can see the permissions for each of the files and directories by typing the ls-l command. So if I were to type ls-l in /home/alex, ls-l, then I would get a list of all the files and then a whole bunch of stuff like this. So what this basically says is I've got a folder called public, a folder called documents, a folder called group stuff, and a folder called private. And you can see that these were, and the dates here, just to the left of the folder names, are the dates that they were last modified. The number to the left of that is the size of the folder and its contents. And this is generally reported in bytes, but you can change that. If you were to add ls-lh, you would get this. This would be changed to 4.0 kilobytes. So it'd say 4.1 or 4.09 KB, or just K. Now the name to the left of the size of the files here is the name of the group each of these folders gets assigned to. And the name to the right of the group here is the name of the owner of the file and folder, or folder. The number to the right of this is the number of contents, is the number of things within, is the number of contents, so like files and subdirectories within each of these folders. And then to the left is the permission string. So what this basically says, and we'll go through this a little bit later, so is basically the public directory here says everybody who has a user account on this system can do anything they want. They can read, they can write, they can delete, they can execute any file or any file within the public directory. Now the private directory basically dashes mean you're not allowed to do that. So what this says is only the owner of this file, only Alex here, is allowed to do anything. Nobody else can touch this file. Nobody else can touch this folder or anything in it. So this is pretty much what I just said. It's permissions. So that whenever you type the ls-l command, you'll get a bunch of results that are formatted kind of in a table like this. You'll get the permission string, the number of contents, the owner, the group, the size, the date of last change, and the name of the directory, or name of the file. So let's talk about that user group, and let's talk about that user permission string a little bit. So you'll see that these permission strings are broken into 10 characters. There's a D or a dash, an R. There's a string that's either that's RWX, RWX, RWX. Now each one of these little characters here can either be R or W, or can either be R or dash, W or dash, or X or dash, respectively. And we'll talk a little bit about what that means. But essentially this string is broken up into a one character indicator to tell you whether or not the item that you're looking at is a directory or a file. And then it's broken into three groups of 3 characters. The first group of 3 characters will tell you what the owner is allowed to do with that item. The second group of 3 will tell you what the group that item is assigned to is allowed to do. And then the third group of 3 characters will tell you what everyone else who has a user account on that machine or on that system is allowed to do to that item. So what these characters essentially mean is R stands for read, W stands for write, and X stands for execute. Consequently, W stands for either write or delete, and X stands for execute. So if some of the files within these directories are programs, then having a permission set to X means that either the owner, the group, or everybody can run that program that's stored there. So the breakdown of this is essentially that everything is essentially that each one of these 10 characters will either be a letter or a dash. In the first position there, a D represents that the item you're looking at is a directory. If it's a dash, then it's a regular file, either a text file, a binary file, a executable file, a program, what have you. But it's not a directory that contains other files. So the first group of 3 characters is the owner group. This is the owner set. This basically tells, like I said, this tells you what the owner is and is not allowed to do. Oops. So the first character there is either going to be an R or a dash. R means that the owner of that file or that item is allowed to read that file. And a dash says that the file owner may not read that file. In the third position, which is the second position within the owner set here, you'll either see a W or a dash. W means that the file owner may write to that file or delete that file, but they may not write. But a dash will mean that the file owner may not write to or delete that file. And then in the third position within the owner set, or fourth position within the big 10 character string, you'll either see an X or a dash. X means that if this file contains a runnable program, then the file owner may run that program. And a dash means that the file owner is not allowed to run that program. Now, these 3 character strings repeat for the group and the user. So for the group permission settings, you will see either an R or a dash, a W or a dash, and an X or a dash. And again, that means the group may read the file, the group may write to the file or delete it, and the group may run the file or not. And the same is true for all users. So I think I should stop there for a minute and see if there are questions. Oh, thank you for attending, Josh. And so do any of those permissions get set automatically? I'm sorry, so do any of those permissions get set automatically to folders like lib? Yes, in Linux there is a default, and I believe I don't know exactly what the default is, but I believe that can be adjusted to determine depending on how the system is configured. In most cases, I think the default will be owner can do everything. Group usually can read and execute, but not write, and all other users cannot do anything. Oh, no, that's okay. So, yes, basically permissions do get set automatically, and that's either some default setting in Linux, or that can be set up, or that can actually be set up by the systems administrator. And then also once that's set up, the systems administrator the systems administrator can either be asked to change those permissions, or they can set it up so that the user can change those permissions. Okay. Any other questions? If not, then I will continue. So in order to set file permissions, you can basically say you can use these character definitions, or you can also use something called octal and binary file permissions. So what the octal and binary representations mean is that they basically give you the ability to set each of the groups of the file permissions separately. So, for example, if I wanted to type RW, if I wanted a setting to be RW, a file to be set to RWX, 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 which basically means anybody on my system can read, write, and execute that file. Then that would correspond to me typing chmod, which we'll talk about that in a minute. But chmod means essentially change the permissions on this file or directory. So I would type chmod 777 or chmod 1118, chmod and then 8 and then 3 and then 9 ones. So what this allows you to do is it's sort of a shorthand for typing. Instead of typing, this is a shorthand for basically typing chmod plus RWX, RWX, RWX. And what this basically means is anytime if you see a 7 in the first position, then that corresponds to all permissions are set to allowed. If you see 6, then it's only read and write that's allowed. If you see a 5, then it's only read and execute that are allowed. If you see a 4, then it's only read that's allowed. If you see a 3, then it's only write and execute that's allowed. If you see a 2, then it's only write that's allowed. If you see a 1, then it's only execute that's allowed. And if you see a 0, then nothing is allowed. So, for example, if you were to type chmod 000 on your file, then not even you would be allowed to edit it anymore. the most common situations I tend to see are either chmod 777 or 770. 777 is very rare because you need to be really careful with that. You need to make sure you need to be very sure that you want everybody to actually be able to look at that file. 750 tends to be more common because what that means is it says as the owner, I'm allowed to read, write, and execute this file, but the group is allowed to read and execute, but not write to the file, and then no one else is allowed to touch it. So here, basically, the numbers 0 through 7 represent something called octal file permissions, and you could also set this as something called binary file permissions, where instead of just a single number, you would have 3 numbers that correspond to the 3 characters within each of the permissions groups. And there you could set 000 for no permissions to that permissions group, 001 for just execute, 010 for just write, 011 for write and execute, 100 for read, and so on and so forth down to 111 for write and execute, where 1 means the permission is allowed and 0 means the permission is not allowed. So 770 and 750 tend to be the most common, like I said, and again, that's why you have these 3 numbers or these three sets of 3 numbers. Those indicate you can either set all the file permissions within that group with a single number or with 3 groups of numbers. So, like I said, chmod is the command you would use for the file. So, for example, if I had a file called documents if I had a folder called group stuff, and that group stuff was set to be allowed to was set such that everything that was within that, both me, the owner, and my group could read, write, and execute those files. If I wanted to change that group stuff so that say for example my group dissolved or I left that group, if I wanted to change it so that only I was allowed to mess with those files, then I could type chmod 700 group stuff. And what this would do is it would change the file permissions on this directory called group stuff to just read, write, and execute for the owner, me, and no permissions for anyone else. Another thing you can do, so you can do the chmod for all sorts of different things. You can use chmod to change the permissions of directories and files, and that's really useful because this is one good way of making sure you have control over who's allowed to see your information and what they're allowed to do with it. chown is another useful command. Like, say for example, you had a data file and you wanted to transfer and maybe you were moving to a different group or something, and you needed to transfer the ownership of that file to another user. Then you can use the chown command, and what that would do is it would change the owner of the file. So it would change that first name in the big long string, in the big long table that we saw from ls-l. It would change the owner from you to or whoever the present owner is to a new owner. So for example, if I wanted to change this documents directory from being owned by Alex to being owned by an individual called me, then what I could do is say chown documents me, and then I would type ls-l again, and instead what I would see is I would see the same documents file, and it would have the same set of permissions, but now the owner and the group would both be me. Consequently, if you have separate user groups, you could then proceed to change the group. chgrp would be the command for a change group. So, are there any questions on file permissions and file ownership so far? If not, then I will continue. So basically, to summarize, there's a whole bunch of useful commands for permission management. So if you want, you can use the who am I command to make sure to remind yourself of what your username is. You can type the ID command that will give you a lot more user identification info with your username. It won't list your password, but it will list your it'll list where your home directory is and various other things. You can type the groups command to list the groups that are currently registered on your system. That'll basically tell you what groups are available. You can type the file X command. You can type the file command, which will basically tell, if you type file and then X or the name of a file, it will tell you what type of file that file is. chmod we talked about before. That's what you would use to change file permissions. chown is what you would use to change the owner of a file from one user to another. The passwd command is a command line way of changing the current user's password. Now, again, you can only do that if you are the current. You can only do that for your own user account, or as the administrator. Now, the sudo command is more like a prefix to every other command. Sudo, you can type sudo before every one of these commands, and if you have the administrator password, or if you're the systems administrator, then you can run any of these commands as administrator. And that, for example, is useful because that would then allow you to change permissions on other users' files. You know, for example, if the systems administrator needed to deactivate a user account, then you could type sudo chmod the user directory and then 000 or something akin to that. So sudo is sort of the equivalent of getting that pop-up for run this program as administrator in Windows. Now, so before I go on to kind of changing topics a little bit, are there any final questions on user permissions? Okay. So another thing that you will do a lot of if you work in systems administration is installing and compiling software. So a lot of times, so in Linux, most of the time, if you're going to install a piece of software, you'll end up using one of the command line package managers. Now, these package managers are basically a program that links to a repository somewhere, usually a remote cloud repository that has a whole giant listing and archive of various programs that have been built by other people, and then what those package managers then will allow you to do is download and install those packages, and it will do all the hard work of compiling and making sure that the files are put in the right places, and it'll do all that for you. In Ubuntu, the package managers these days are either apt or snap. CentOS and Red Hat use Yum. Brew is another one, and there's a bunch of others. There's Pacman and Arch Linux, and the list goes on. Consequently, a lot of programming languages these days it seems to be pretty popular for programming languages these days to come with their own package managers. Not quite sure why, but it seems to be pretty popular these days. So what these programs will do is they will download the pre-compiled, pre-packaged version of a program that you want, and it will do all the hard work of installing it for you in the background. And all you would have to do is type apt-get or snap and then install and the package name, and it would go off and find the package for you in the repository, download it, install it, and clean up and do everything in the background for you. Now, if you're lucky, the software you would like, the software you want will be packaged like that. But this is not always the case. Sometimes it's not that easy. Sometimes, and in fact, more often than you might think, particularly in scientific and engineering applications, software will just come as a compressed zip file that contains a bunch of code. And then you'll have to, and usually it'll come with a make file or some sort of configuration file. But you'll have to do some work to compile and assemble that program into a working program, and you'll have to do some work as a systems administrator to get it put in the right place and installed and available for the users it needs to be available to. So what this essentially means is that at some point, more than likely, you'll have to compile the program. And compiling is just the process of taking a piece of code in a compiled programming language like C or C++ or Fortran or Java, and turning it into a representation that the computer can understand. Now, there are a ton of different options for compilers. These days, there are things like, there's the GNU compiler package, and this contains a whole bunch of compilers that are free and open source, and they're very good. GCC and Gfortran are the two big ones. They're the GNU C compiler and the GNU Fortran compilers. There's GHC, which is the GNU Haskell compiler. Haskell is a interesting functional programming language. There's MCS, which is the Mono C# compiler. VBNC, the Mono Visual Basic compiler. And then there's also a market for proprietary and paid compilers, and Intel and the Portland Group seem to be the two big ones these days. ICC and iFort are the Intel C and Fortran compilers respectively, and there's PGICC and PGIFort for the Portland Group compilers, and there's a gigantic list of other ones. Usually every programming language comes with one or more of its own compilers. So just running a compiler on a piece of code is good and well and it works really well if your program is small and only has a couple of different files. But more often than not, the programs you're going to install contain dozens or hundreds of files. And the process of compiling and linking each one of those together into a complete program, you don't want to do that by hand. So there's a good program called GNU Make, and many programs that are distributed as zipped files of code will come with something called a make file, and this is basically just a script that will configure everything for you and set up and do all the compilation for you. Usually you'll have to set a few things. You'll have to set a few options, and you may have to configure your environment variable, and you may have to try it a few times to get it to work. But this is sort of the command line way of automating the process of compiling huge amounts of code. There is also another thing that you might want to do so before I go on to cron, are there any questions on programs and installing and compiling programs? If not, I will go on to task automation. So one other thing, and I actually think this might be the last thing here, is another thing that's really nice to do is a lot of times as a systems administrator or a IT professional, you're going to end up having to do the same thing over and over and over again. So sometimes if you happen to know that you're going to have to do a specific task at a specific time, and it's going to repeat on a pretty much guaranteed cycle, then that might be a task that's a good candidate for automation. And so there are a ton of different IT automation tools out there, but the big one on Linux is something called cron. And cron is a system daemon, which means a program that runs in the background. And what it's designed to do is automate tasks that repeat on a very regular basis. And so it generally it takes in a big manifest file of different commands to execute, and those commands are prefixed with a set of numbers. These sets of numbers are the number of minutes between repeats, the number of minutes between command executions, the number of hours, the number of days, or the number of hours, the day of the month, and the day of the week. So for example, this is essentially saying repeat this command at, on this day, on this month, on this month of the year, on this day of the month, on this hour, and on this minute. Now if you leave anything as a star, it will say, basically, for example, if I said 6 *** here with 6 or *** 6, then that would say repeat this every Saturday, and repeat this command every single Saturday until the end of time, or until I tell you to stop. Now the more stars you replace with numbers, the more specific you can get, to the point where you can even get it down to the point where you're really repeating this once a year even. And this is actually really useful for running system checks, running updates, and all of that stuff all that sort of repetitive stuff that you might have to do multiple times. Cron is a great way of automating that, so you don't have to go in and type the commands over and over and over again. So that is the end of the systems administration and Linux talk. The last little bit here, I'll talk a little bit about RCC resources. But are there any last questions on the systems administration and Linux stuff?
I'm sorry, could you go back to the previous slide for just one more minute?
Certainly.
Thank you so much.
Sure.
All right, perfect. Thank you.
No problem. Are there any other questions? Every time I open the chat, it likes to send me to the next page. Okay, perfect. So last little bit here, we'll talk a little bit about the Research Computing Center. So the Research Computing Center is the major source for research computing on campus. And what this basically means is supercomputing. We help support scientific computing. We help support computing intensive research endeavors. We offer consulting services. We offer computing services. We even offer free computing services. So if you get an RCC account, you'll get access to some free resources, including a home directory, 150 gigabytes of storage, and you'll be able to run programs on our general access and backfill partitions. And that's a great way to get started with research computing once your computer needs get sort of scale outside the realms of what your laptop or desktop can do. So we have the supercomputer, which currently has, I think, more than 16,000 cores right now. We've got close to 800 nodes. We've got the Spear machines, which are dedicated nodes intended for interactive jobs. And we've got research archival storage, which is basically you can get terabytes upon terabytes of storage for a relatively low cost, and that's really useful for research groups that are going to generate huge amounts of data and need a place to store it. One of the big reasons for running this workshop is that all of RCC's computing systems run CentOS, which is a variety of Linux that's based on Red Hat. That's sort of based on or very similar to Red Hat Linux. So if you use the HPC or you use any of RCC's resources, you will probably need the skills learned in this workshop. RCC uses a job scheduler called Slurm, and actually there's going to be another workshop on Slurm and Introduction to the HPC coming up, I think next week. So if you're interested in that, definitely check that out. So there will be a link to these slides, and there, since this has been recorded, actually, I think there will be a link to the talk itself on RCC's website and probably on the library's website too. And if you want to learn more about this, there's a little link here that will take you to a free and open source Linux book. So does anybody have any last questions?
I'm so sorry. Could you show the link to the free Linux book one more time?
Certainly.
Thank you.